What's going on, guys? Let's look at this problem right here. Here the question is asking for arbitrary complex constants w1 and w2, prove or disprove the following. The first one is asking prove that real part of the j w1 is equal to negative imaginary part of the w1. Now in order to do that, first we have to pick up a complex number. Let's say our complex number is w is equal to x plus jy. Now we want to prove real part of the jw1 is equal to negative imaginary part of the w1. Okay, now in order to do that, first we have to create a jw1 equation. So if I multiply, okay, let's say this w1, so jw1 mean we are multiplying this one by j, so jw1 is equal to j times x plus jy, and here we are going to have jw1 jx, and this is going to become minus because j is equal to square root of -1, and therefore j square is going to be -1. So when we multiply here, this is going to become j square, so that's going to be -1 right here. -1 times y, that's going to be just -y, right? Here the question is asking to look for the real part of the jw1. Real part of the jw1. And if you look at the real part, here this jx is, if I rearrange this one, real part of the, if you rearrange this one, this is going to be -y, this is our real part, plus jx. Jx is the imaginary part. So since we are looking for the real part is -y, right? And if you look at this one, -y is what? For this one, the original function, y is imaginary, but here we have negative. This is positive y, this is negative. So this is negative imaginary part of the w1. So therefore we proved real part of the jw1 is equal to imaginary part of the w1, negative imaginary part of the w1. So this is a proof for the first one. Now let's look at the second one. The second one is asking b part is asking imaginary jw1 is equal to real w1. Okay, now let's go ahead and do that. Again, it's going to be the same thing. We have derived until here, we have derived an equation for jw1. It's going to be the same thing. So if I grab this one here, jw1 is equal to jx minus y, right? So we are looking for imaginary part. Imaginary part of the jw1 is equal to imaginary part of the jx minus y. Here you can see this -y is the real part. This jx, because since we have j combined with x, this x is the imaginary part, right? So imaginary part of this jw1 is x. And if you look at the x in our w1, x is the real number, right? So we can say imaginary part of the jw1 is equal to real part of the w1. And therefore we proved the second one. Okay, now let's go for the third one. Let's get rid of these two. Okay, the third part is asking real part of the w1 plus real part of the w2 is equal to real part of the w1 plus w2. So in order to do this one, before we had w1 is equal to, we are doing the c part, before we had w1 is equal to x plus jy. Now we have to have another one to prove this one, because we are we are dealing with w2 too. So w2, let's create a function based on another term like p plus jq. So this is another complex number. Here we want to prove real part of the w1 plus real part of the w2 is equal to real part of the w1 plus w2. Okay, let's go ahead and do that. First, I'm going to add these two together. Real part of the w1 plus, okay, real part of the w1 plus w2, and let's add them together and see what we get. w1 and w2, if you add them, you are going to get x plus jy, that's the first one, plus p plus jq, that's the second one. Okay, so we add them together. Now let's try to simplify this one. Real part of the x plus jy. Okay, so we can bring all the real part together here we have two real part. X and P are real part, JY and JQ are imaginary part. So X plus P plus JY plus JQ. Okay, so from this one we can say that real part of the X plus P and then plus, okay, let's put it like this. Here we can take plus J common, so this is going to be Y plus Q. So real part of the, we are looking for the real part of the W1 plus W2, right? So in that one, here we have real part of X plus P is the real part. This J, Y plus Q is the imaginary part. Here you can see, whenever we have something with J, this is imaginary, this is the real. So we can say X plus P is the real part of the W1 plus W2. So we have derived this one, therefore we can say real part of the W1, because this is real part of the W1, that is this one X, and plus real part of the W2, that is P, that's what we derived, that is equivalent to real part of the W1 plus W2. So therefore we proved this one true. That's the third one. Okay, and that's how we do that. I hope this helps. Thanks for watching.